Okay, for topic two, we're going to talk about equivalent fractions, and this is going to be an important thing that actually comes up, multiple times in your math career, okay? So, luckily, it's not the hardest concept to understand, so try to remember a few things about this, and it won't be too bad. So, we do have a couple of definitions that we need to understand here. So, fractions that represent the same portion of a whole or the same point on a number line are called equivalent fractions. So, that's kind of a formal-ish definition. Basically, equivalent fractions, they look different, but they represent the same amount. So let's talk pictures here. Pictures are always nice. So imagine you and your bestie have candy bars that are the same brand, same size. Okay. Now remember, I mentioned this in the previous video. When you're drawing pictures by hand, just it doesn't have to be exact, but pretend. Okay. So squint your eyes until you see two identical candy bars. Let's say they're Crunch bars. Okay. It's already looking tragic. All right, let me see if I can fix this one. All right, so pretend these are exact same candy bars. You and your friend have identical candy bars. Good Lord, the harder I try to make it perfect, the worse it gets. There's got to be a way to like copy and paste. I'm just not that tech savvy. Okay, so we've got our two identical Crunch bars. Okay, they're identical, the same shape, the same size. They're exactly the same. And let's say you cut yours in half and you eat one of the two pieces. So you eat one half, right? But let's say your friend cuts theirs into four equal size pieces and they eat two of the four. So the question is, who ate more? Well, if you look at these candy bars, you would say, well, your friend ate two pieces, but you only ate one piece. So did your friend eat more? Well, no, because their pieces were smaller, your piece was bigger. So at the end of the day, if you're just counting gram for gram or crumb for crumb of this candy bar, you ate exactly the same amount of candy. So we have two different ways to represent the exact same amount, one half and two fourths. Again, we can see it visually. You took your candy bar, you split it into two equal sized pieces, you ate one. Your best friend took their exact same shape and size candy bar and they cut it into four equal sized pieces and ate two. All right, you ate the exact same amount of candy. So we have two fractions that very much look different, but are for sure equal. Okay, those would be considered equivalent fractions. Okay, now to determine if two fractions are indeed equal, we compare something called cross products. And to explain cross products at this point in your math career, it's easier to show you. Okay, now if we had two fractions, let's say a over b, and we're claiming that, hey, this fraction a over b is exactly equal to c over d, there's a quick way we can check. We can multiply the diagonals, and if those cross products are equal, then the two fractions are equal. So we would multiply a and d, and if that equals, let's change colors here, if that equals b times c, then we can say the two fractions are equal. So let's look at the example with the candy bars, okay? So we're making a claim that one half is equal to two fourths. So we would multiply the diagonals, and that gives us our cross products. And if the cross products are equal, we can say definitively, so are the fractions. So I would take 1 times 4, and if that equals 2 times 2, then those fractions are equal. And guess what? 1 times 4 is 4. 2 times 2 is 4. We would say the fractions are equal. And the fractions are equal because their cross products are equal. So that's a really quick, easy way that we can determine without a ton of work if two fractions are equal. Okay. Now, there's another thing that you'll be asked to do, and it is to create equivalent forms of fractions. So you have a fraction, but it's maybe not in the right format for you. So is there a way to get an equivalent version of that fraction that does work out for you? This comes up a lot when you add and subtract fractions. So this is like really, really important. But to create equivalent forms of a fraction, you multiply the numerator and denominator by the same natural number. And so you're going to have a fraction that very much looks different, but is absolutely equivalent to what you started with as long as you multiply the top and bottom. And I'll show you what I mean by that in just a moment. So let's look at our examples. So first example is example 4, and it says determine if each pair of fractions is equivalent. Okay, so we're going to do that whole like multiply the diagonals. So we're going to multiply 4 and 15, and then we're going to multiply 6 and 10. And if those cross products are equal, so are the fractions. So what we're really checking is, does 4 times 15 equal 6 times 10? And I'm going to put a little question mark there because we're not sure yet. Okay. Well, 4 times 15 happens to be 60. And if you don't believe me, we can go to the calculator. Or if you have a multiplication table, I almost kind of prefer to use the multiplication table for something easy, but 4 times 15 is indeed 60. And then the other cross product was 6 times 10. Students don't generally struggle with that, but just to be super clear, 6 times 10 is 60, okay? So we can say that these cross products are for sure equal, which tell me the fractions are equal. So 4 times 15 is 60, 6 times 10 is 60. Those are definitely equal, so we would say the fractions are equal. Or you could say, depending on how the question is worded, you could just put a yes. Either way, these are equivalent fractions. Okay. So next up, we have 2/5, and then we have 7/15. So let's do our cross multiplying. My dog is going at it again. We have 2 times 15, and we want to know, does this equal 5 times 7? Okay. Well, 2 times 15 is 30. So either use a multiplication table or a calculator if you're unsure of that. But then 5 times 7 is 35. So we have these cross products that are not equal. And in math, when we want to say not equal, we do a regular equal sign, but we put a little like diagonal slash through it. So this means not equal. If the cross products are not equal, the fractions are not equal. So we would say the fractions are not equal. My poor dog is so mad at my neighbors right now. They're preparing for a yard sale and they're ignoring her. And I want to go out there and smack them because my dog is actual perfection and they're ignoring her. And that's why she's barking. Anyway, example 5, back to the topic at hand. Determine 2 equivalent forms of each fraction. This idea is going to be really, really big because we're going to use this a lot when we get into adding and subtracting fractions. So kind of pay close attention here because this is for sure going to come back up. So we have the fraction 3/4, and the directions say come up with 2 equivalent forms of this. For every fraction out there, there are just oodles and oodles, infinitely many equivalent forms. All you have to do is take the fraction, and technically what you're doing is you're multiplying it by 1. But the directions up here, let me show you again. The directions here say to create equivalent forms of a fraction, multiply the numerator and denominator by the same natural number. Well, let's think about what that is. So let's go down here to 3/4. Let's say we decided to multiply by the natural number 5. So I want to multiply 3 by 5 and 4 by 5. Well, let's think about this right here. What is 5 divided by 5? Well, 5 divided by 5 is really just 1. So this is secretly 1. So remember, when you multiply a number by 1, you don't change the value of the number. Any number times 1 is just that number. But when you're dealing with fractions, if you have what some people will call a well-chosen 1, you've changed the appearance of the fraction, but you have not changed the value of the fraction. So if we have 3, my dog now has a bottle that she's chewing. If we have 3/4 and we take 3 and 4 and multiply them both by 5, we would get 15/20. And what that tells me is 3/4 and 15/20 are equal to each other. They don't look the same, but they're certainly equal. And if you really wanted to check cross multiply, we would want to see, does 3 times 20 equal 4 times 15? Well, 3 times 20 is 60. And 4 times 15 is 60. So now we can verify for sure that 3/4 is equal to 15/20. Okay, let's try another one. So we're still using 3/4, but we want to multiply top and bottom by some other natural number. So let's say we multiply by, I don't know, 10. So we multiply top and bottom by 10, which is a really secret form of 1. So that gives me 3 times 10 is 30. 4 times 10 is 40. So what we can say here is these two numbers, 3/4 and 30/40 are equal. It also tells me that 15/20 is equal to 30/40. They're all equal, okay? And we can test it. So we can say, okay, for 3/4, we want to take, to see if 3/4 is equal to 30/40, we want to take 3 times 40 and see if that equals 4 times 30. Well, without jumping over to the calculator, maybe take me on faith here. 3 times 40 is 120. 4 times 30 is also 120. So we've proven that 3/4 equals 30/40. Now for fun, let's prove that 15/20 equals 30/40. So we would take 15 times 40 and set it equal to 20 times 30. Now these numbers are a little bit bigger, so we can jump over to the calculator. So let's see, we're checking 15 times 40. We get 600. And then we were checking 20 times 30, and we get 600. So we've proven all of those different fractions really are equal to each other, okay? So everybody's equal, everybody's happy. Let's look at the next example. So for part B, we do have a negative fraction, and I don't want you to get too bent out of shape about negative fractions. If a fraction is negative, all of its equivalent forms would also have to be negative, okay? So we're going to take -6/11 and we want to multiply by any natural number. You could literally pick any number on the plan, any natural number, and keep just getting equivalent form after equivalent form. But let's say for the sake of this one, let's multiply top and bottom by 3, okay? I pulled it out of thin air. Well, this is our secret form of 1. So remember, if a fraction is negative, all of its equivalent forms have to be negative. So I'm just going to carry the negative over. And then 6 times 3 is 18. And then 11 times 3 is 33. So that tells me that -6/11 is equal to -18/33. Okay? Let's find another form. So we still have -6/11. Let's multiply top and bottom by, I don't know, 5. It doesn't really matter. Any natural number will do. So remember, if the fraction itself is negative, the equivalent forms would obviously have to be negative. So I'm just going to bring my negative over. And then 6 times 5 is 30. And 11 times 5 is 55. So I can now say that -6/11 is equal to -30/55. And if you want to check it, you can do the cross product thing to verify these answers, okay? So make sure you understand how you can create equivalent forms of fractions because it will be important in a later section, okay?